today's lesson, section 3.2b, talking about polynomial functions and their graphs. So here we're going to talk a little bit more about the specific graph and some things that happen. Here we're talking about local extrema, and these are points on the graph of the function where there appears a max or minimum in a given area. So what I'm talking about is like if I have something like this, right there, there's like a low point. So it doesn't really cross the x-axis or anything, and even if it did, that's fine. But there's a low point there. So it like goes up, and then it comes back down a little bit, and then it goes back up. So that becomes a local minimum. And over here, we got to a high point before we went back down and then went straight up. So like obviously overall, the min and max of all your polynomial functions are going to be infinity, unless it's like a parabola or something like that where it's like even, so your arrows go both in the same direction, so that creates either a complete min or a complete max. But most of the time you're going to get these little undulations because of the terms that are in your polynomial functions that create local mins and local maxes. Okay, so that's what they're kind of looking for. Now, one thing to remember for a polynomial function of the given form and has a degree of n, then the graph has at least, or at most, n minus 1 local extrema. So if it's like to the third power, it's got 2, or at most 2 local extrema. Maybe it won't, but at most, like that's like most it can have. Some of them are like, if you just have x cubed, even though it's to the power of 3, that one's really not going to have any, because look, there's nothing that's created. But if you have like x cubed plus 3x squared plus 5x minus 2, something like that, then maybe you have those undulations because of those values, and then that creates some fun stuff for your picture and creates those local extrema. Okay? Now, we talked about this in the last video, it's multiplicity of a zero. So this just means that you have a number of zeros at the same values. So then here, if you have a number of zeros at a value c, and it is odd, so like you have 3 of them, or 5 of them, or 7 of them, then that means the line passes through the x-axis, but it also like starts to become flatter as it gets closer to your x-axis as it approaches. So it comes steep, and then it like kind of becomes more of a line, and then it shoots back up after it crosses. Also, the number of zeros at a value of c, when it's even, the line touches the x-axis and then turns back in the same direction. But it does the same kind of thing. As you get more of them, the line becomes flatter and closer to your x-axis because of the number of them, because you're creating a higher power, which creates fractions closer to the x-axis. Okay? So here we have a fun graph that has multiple multiplicities. Okay, so let's recognize what our zeros are first. So I've got 0, or zeros at 0. I've got some zeros at 1, some zeros at -2, and a 0 at 5. Okay, so looks like I got 3 here, 4 here, and 2 here, and just 1 here. Okay, so let's plot those values. Okay, so now let's look at all of them. So since I have x cubed, x to the 4th, x squared, and just x, my power of my polynomial, or the degree, should be whatever 3 plus 4 plus 2 plus 1 is. So that gets me x to the 10th. So here it's even. Okay. And then it's also positive, because looking at all my x's, I have no coefficients other than 1. So then that means it's a positive number here. So then it should be in a polynomial where the arrows end up going in the same direction at the end. Okay? So then now I want to create this. So as I come from positive infinity to, so I'm working from left to right. So as I'm coming down from positive infinity to my first 0, at -2 it's even. So let's try this again. So as it's even, then that means that I'm going to touch this polynomial, or touch this x-intercept, and then I'm going to head back in the same direction. Then the next one is 0, and it's odd. So then I'm going to cross. Let's try that again. I'm going to cross it, and then at 1, I've got 4 of them. So then I cross at 0, and then I'm going to touch the 1 and head back in the same direction. So I was coming from -infinity, so now I'm going to go back to -infinity. And now for the 5, I've only got 1, so I'm going to go straight through and head to infinity like I'm supposed to, because that's my end behavior, because it's even positive. So recap, so at -2 there was an even amount, so I touched and went back from where I came. But then I have to eventually come back to 0, so you have to come back to here. And then I got to 0, it was odd, so that means it's going to go through. And then, but the next one's really close afterwards because it's 1, but then 1 has 4 at it, so it's going to touch that 1 and go back. So I was coming for a little while, coming from -infinity, so I'm going to head back to -infinity. And then eventually I have to get to 5, so then it's going to be, since there's 1, I just go right through, no worry there, and then head to infinity like I'm supposed to. So I have the correct even or end behavior like I'm supposed to. Okay, have fun.